If a function fx is equal to x for x less than 1 and the function fx is equal to 2 minus x for x lies between 1 and 2 and fx is equal to minus 2 plus 3x plus x square for x greater than 2, and so that the function fx is not differentiable at x equal to 1. So at x equal to 1 means you have to take this function, that is fx is equal to 2 minus x, because fx is equal to x for x less than 1. So this function we will not take this function, and this function is for x greater than 2, but it is given to show or to prove that, or so to show that it is not differentiable at x equal to 1. So at x equal to 1, here x value lies between 1 and 2. So we will take the function fx is equal to 2 minus x, and we will see that whether the function is differentiable or not. We know from the definition of differentiable of a function that a function y equal to fx is differentiable at x equal to x0 if the right hand derivative r f dash x0 exists, the left hand derivative l f dash x0 exists, and right hand derivative is equal to the left hand derivative. And we will see whether the right hand derivative will exist or not and the left hand derivative will exist or not, then we can prove that the function is differentiable or not differentiable. For the right hand derivative, we write the derivative from the first principle of derivative, that it is limit f x0 plus h minus f x0 divided by h approaches to 0. And here the given function is 2 minus x. So 2 minus x plus h minus 2 minus x divided by h, because we will check the function 2 minus x. So we will take x is equal to x plus h, because it is right hand derivative. We will take a value slightly greater than x, so x plus h, and here for fx it is 2 minus x divided by h, and we are checking the derivative at x equal to 1. So put the value of x equal to 1. So limit 2 minus 1 minus h minus 2 minus 1, because x value is equal to 1 divided by h, and if you solve it, it will be equal to limit 2 minus 1 is equal to 1 minus h minus 1 divided by h. So 1 cancels, minus h divided by h, so it is equal to minus 1. So the right hand derivative of the function at x equal to 1 is equal to minus 1. Now let us check the left hand derivative. For left hand derivative, we use this formula, that is limit x0 minus h minus f x0 divided by h approaches to 0. So the left hand derivative will be equal to limit 2 minus x minus h minus 2 minus x divided by h, because you are taking the function 2 minus x, and at x equal to 1 you put the value of x equal to 1. So limit 2 minus 1 plus h minus 2 minus 1 divided by h, and this will be equal to 1 plus h minus 1 cancels, so h divided by h, this is equal to 1. So you see the left hand derivative is not equal to the right hand derivative, because right hand derivative is equal to minus 1 and left hand derivative is plus 1. So right hand derivative is not equal to left hand derivative. That is why the function is not differentiable at x equal to 1.